In this lesson, we are going to talk about money, which is always a good thing, and you can't argue that it's definitely a practical topic. So that's what we're going to get started on. We're going to talk about compound and continuous interest. So the basic interest calculation, if you were to deposit money in a bank, we would start with a principal amount. That's the amount that you deposited, and the basic interest calculation would be 1 plus the interest rate. Interest is given as a percent. You would convert it to decimal. So for example, if I put $1,000 in an account and I didn't put anything else in, and that account pays a whopping 6% interest once a year. You're never going to find that except in the stock market, but let's just say that happens. Well, that means if I wanted to find out my new balance at the end of the year, it would be 1,000 times 1.06. So the total amount after 1 year would be 1,060. The interest part is the $60, and the 1,000 was the original. So that's all well and good if you compound it once a year, but let's see what happens when I compound this interest monthly. And to do that, this is an annual interest rate, the 6%. So if I'm going to compound it monthly, I've got to convert that to a monthly rate, because banks won't give you a monthly rate. They always give you an annual rate. So you just take the 0.06 and you divide by 12, and you get 0.005. Let's see what kind of difference that would make. So I would start with my 1,000, and after month 1, I would be multiplying that by 1.005. And after month 2, I'd multiply that answer by another 1.005, and you would keep doing that all the way until month 12 with another 1.005. So think to yourself, how many of these 1.005s am I going to use? Or am I going to multiply that guy by? Let me change my little pointer because I like the hand. So how many of these do I have? Well, I got 1, 2, 12 of them. So if I'm going to write this in a little bit shorter, it would be my principal, which is 1,000, times 1.005 raised to the 12th power. And that's going to yield 1,061.68 cents. So by compounding monthly instead of annually, I get another $1.68 out of it, which is nothing for $1,000. But what if this were $1 million? Then it starts to make a difference. That's how millionaires get rich and stay rich, because it takes money to make money, and it's all in the beauty of compounded interest. There's a couple definitions that we have to talk about, then we're going to work through a few examples. The FLCC book talks about a nominal rate versus an effective rate. Now, the banks always give you a nominal rate, so nominal. That word stands for in name only, because usually the rate isn't exactly the nominal rate. The nominal rate is the same as an annual rate. So if you are compounding annually, your rate is the nominal rate. The effective rate is a little bit more complicated. The effective rate is the actual rate. And here's the formula. It's a bit much here. It's 1, but we kind of did it up here. We calculated the effective rate. It's all embedded in this guy. So the effective rate is 1 plus the nominal rate divided by how many times you are compounding in a year. Let me see if I can write all this. Compounded. Oh, that doesn't look very nice. Okay. And then you take that and you raise it by the number of times compounded. And then in the end, you've got to subtract a 1 off of that. So that's a bit nutty. We will rewrite it again in class, but let me just talk about it one more time. I'm just looking for the rate. So up here, this is like a growth factor. I want the effective rate. So what you would do, it's 1 plus the nominal rate divided by the number of times compounded. We did this calculation right up here. That's the nominal rate, compounded 12 times. So the 1.005 is this part right here. Raised to how often it's compounded, that's what the 12 is. But then your answer is going to be a 1 point something. If I'm just trying to find the rate, you've got to subtract away the 1. So let's walk through this example and see how it goes. Okay, so here's our example. What are the nominal and effective rates of an account paying 4% interest, compounded annually and compounded monthly? So this is the rate that the bank gives me. So for Part A, we'll call the compounded annually Part A. Basically, the nominal and the effective are the same thing. If I'm compounding annually, then this number is 1, and that's 1. And so everything, the ones will subtract away, and the nominal is equal to the effective rate. So the nominal is equal to the effective rate. And that's going to be 4%. That's easy. So now let's do compounded monthly. Compounded monthly, the nominal is 4%. That does not change. It's the annual rate. The effective, we have to go through and calculate, because we have to figure in the fact that it's being compounded 12 times a year. So here we go. This is just the rate. It's 1 plus the nominal rate is 0.04. We are compounding 12 times a year, raised to the 12th power. You calculate that and then subtract away a 1. It doesn't seem nearly as complicated as it was before. When you do all that, you end up with 0.0407. So the effective rate is 4.07%. So think to yourself, why is my effective rate slightly larger than the nominal rate? And if you think about it, it's because you are earning interest on interest. You are compounding 12 times a year, so you're getting just a little bit more out of your money because you're earning that interest on interest. All right, so we skipped example 2. We're going to do that one in class, and now we're down on the second page, part E, formula. The formula for compound interest looks like this. We say B, capital B, is the balance. The balance in our bank account is going to be equal to, P is the principal amount that you put in. This is assuming that you put in one chunk of money and you don't put anything else. And it's going to be 1 plus the nominal rate divided by how often it's compounded. But now, if we're talking about multiple years, it's going to be how often it's compounded, that's N, times T, which is the number of years. So we're going to write all this out. B is the balance. How much money is in your account? P is the principal amount. So that's the initial amount. That's how much you put in at the beginning. R is the nominal rate. That's how much, that's the rate that the bank quotes you, as if it were an annual rate. And N is the number of times a year. For 1 year it's compounded. If your money sits in there for multiple years, then T is the number of years. So we're going to work a direct substitute in, crank out an answer kind of problem. Coming up next, Susie. Susie put in $500 in an account. And again, you will not find a bank account with this kind of interest rate, but somehow she's in magic land and she has a nominal interest rate of 6%. I think rates now are more like 0.6%, but whatever. And it's compounded monthly. We want to know how much money is going to be in her account after 3 years. She doesn't put any more in and she doesn't take anything out. So basically, I want to find my end balance. The initial amount is 500. 1 plus, my rate is 6%, so I convert that to a decimal, 0.06. If I'm compounding monthly, that means I'm dividing by 12. And then that has to be raised to an exponent. You've got to put this in parentheses or you will make this mistake. I see it every year. 12 times 3. Everything, that entire thing is the exponent. So you got to think about, when you get your answer, you got to think about what would be reasonable. 500 bucks, 6%, that's a great interest rate. 3 years, you're probably not going to make $1,000 out of that. So when I crank this number out, I get 598 and 34 cents. Make sure your answer makes sense. So by just letting her money sit there, she earned another 98 bucks. That's not too bad. Again, 98 bucks doesn't seem like much, but think about what if she had $1 million and she did this. We're going to talk about that in class. Okay, so part B of this, how much money is she going to make? Let's say we compound daily. So for daily, let's assume it's a regular year and there's 365 days in the year. Well, all I do, I have the same principal amount, I have the same nominal rate, but now I'm dividing that by 365. At the same time, I'm raising that to an exponent of 365 times 3 years. So figure that out, and you end up with 598 and 60 cents. You didn't earn much more. So there is kind of a limitation to how much interest you can earn on interest. So we've seen that there isn't much difference between compounding monthly and compounding daily. What if we wanted to compound instantaneously, every single second of every day? Well, we can come up with a different formula for that, and it's based on what we talked about yesterday. Remember, if I take this expression, and as n goes to infinity, this turns into the number e. Well, if you look at this, this is a lot like our interest rate. N is the number of times compounded. So if I want continuous interest, I'm going to have an e in my formula. So my balance this time is the principal times the number e raised to the RT. Because I don't have a number of times compounded anymore. It's infinite. So B is still the balance. P is still the principal. I'm writing too fast, so it's sloppy. R is still the nominal rate. And T is time in years, number of years. So this makes a simpler equation. Now, to talk about continuous, nominal, and effective rate, the rate you're given is going to be the nominal. That's easy. And the continuous rate, or the effective rate, is going to be e to the r, whatever you get there, and then you'll have to subtract the 1 away. That's the effective rate for continuous compounding. Okay, that's the effective rate. So a couple final examples here. What is the effective annual rate of an account that pays a nominal rate of 6%, compounded continuously? Well, e to the r minus 1. That's the effective rate. So e to the 0.06 minus 1. It's going to be approximately 6.2%. Again, if I'm compounding every second of every day, instantaneously, my effective rate should be just a tiny bit bigger than my annual rate because I'm earning more interest on interest. All right, find the amount after 3 years of $1,000 is invested at 12% a year, compounded continuously. You're going to use B is equal to P times e to the RT. I want you to figure out where these numbers are going to go. And we will go over that in class together.